Hello grade 6. In this video I'm going to re-explain everything we have taken in the last week in class. So since most of you couldn't attend the class, so they will be able to understand everything, and I advise you after watching this video to solve the worksheet found on the drive. We are going to explain about angles. As you look at this diagram, you will see that an angle is formed when two lines meet. The size of the angle measures the amount of space between the lines. In the diagram, the lines BA and BC, we call them the arms of the angles, and the point B, where the two lines meet, is called the vertex of the angle. If you want to name an angle, you have to use 3 letters. The vertex should be in the middle, and the extremities are the sides of the angle. So for example, an angle is named ABC or CBA. As long as you put the vertex in the middle, the answer will be correct. How do we measure an angle? You know that you have to measure an angle using a protractor, and there are types of angles. The right angle is any angle that measures 90, where the arms are perpendicular to each other. A straight angle measures 180, where it forms a straight line. An acute angle is any angle that's less than 90. An obtuse angle is any angle which is greater than 90 but still less than 180, because 180 is a straight angle. Let us do this activity. Look at the angle, name it, and give me the type of the angle. As you know, you should put the vertex in the middle. Okay, and you can name it ABC or CBA. As long as you put the vertex in the middle, the answer is correct. If you just look at the angle, it's very obvious that it's an acute angle, but if you want to know the real measure of the angle, you have to use a protractor. The second angle is E. The vertex is E, so it should be in the middle. So it's FED. And it's also an acute angle because it's less than a right angle. The third one is JH, the vertex in the middle, don't forget G. And it's obvious that it's an obtuse angle. Okay, and the last one is ACD, and it's also an obtuse angle. Now we are going to talk about adjacent angles. Adjacent angles are angles that have the same vertex, they have a common side, and the common side should be situated in the middle, inside the big angle. Let us discuss about some cases. Look at the first figure. We are going to talk about UBN and UBM. Do they have the same vertex? Yes, they have. It's B. Do they have a common side? Yes, they have a common side, which is UB. But is UB situated in the middle? No, it's not situated in the middle. So those two angles, we cannot say that they are adjacent. Look at the second figure. We have XAY and ZAT. Do they have the same vertex? Yes, they have the same vertex, which is A. But do they have a common side? They don't have a common side. So we cannot say that those two angles are adjacent. Look at the third figure. We have ROS and SOV. Do they have the same vertex? Yes, it's O. Do they have a common side? Yes, it's OS. Is OS situated in the middle? Yes. So we can say that ROS and SOV are adjacent. angles on a straight line, they form supplementary angles. Look at this figure. I have a straight line or a straight angle. We draw a line which is inside the angle. So now we have two angles formed. The sum of those two angles is 180. So we call the angles supplementary angles. While if I have a right angle and we draw a line inside this right angle, we are going also to obtain two angles, but in this case the two angles we call them complementary angles because their sum is 90. So when the sum is 180 we call them supplementary angles. When the sum is 90 we call them complementary angles. Let us complete the following. Two angles, their sum is 90, we call them complementary. Two angles, their sum is 180, we call them supplementary. And now in number 2, we need to draw two equal adjacent supplementary angles. So the angles should be equal, adjacent, and supplementary. So the first thing I'm going to do is to draw a supplementary angle. If they are equal, then every angle should be 90. So as you see, now I have two adjacent, supplementary, and equal angle. Each one measures 90 degrees. In the second one, we need to draw two equal, adjacent, and complementary angles. So the first thing I'm going to do is to draw a right angle. Then I draw a line in the middle. In a case, each one is going to be 45. Now in question number 3, observe the adjacent figure and answer each of the following questions. Are the angles LOE and VOE adjacent, supplementary, and why? So you have to prove that they are adjacent and you have to prove that they are supplementary. If you look at the figure, do they have the same vertex? Yes, it's O. Do they have a common side? Yes, it's OE, and it's situated in the middle. So till now, yes, they are adjacent. We still need to prove that they are supplementary. If you add 155 and 25, you will get 180. So yes, we can say that those two angles are supplementary. So we can say that yes, LOE and VOE are adjacent, supplementary. Do VOL collinear? Yes. If you still remember that collinear means they form a straight line, and to have a straight line they should form a straight angle. And since we proved that VOE and EOL they make 180 degrees, so yes, they are collinear. Now we are going to talk about vertically opposite angles. Look at this figure. Two intersecting lines, they form four angles. From the diagram, you can see that A plus C equals 180 because it's a straight angle. Also B plus C, straight angle. So A plus C, it's equal to B plus C. Just cross out C from both sides because they have the same measure. So you will get that A equals to B. And starting from now on, we say that A is equal to B because they are vertically opposite. Also C and D, if you do the same operation, you are going to get that C is equal to D. So we say also C is equal to D because they are vertically opposite. So two intersecting lines, they form two pair of vertically opposite angles. And now an exercise about vertically opposite angles. If you observe the adjacent figure, you have to list all the vertically opposite angles. XOV, I'm going to mark them. XOV is vertically opposite to UOY. Why? Because they have the same vertex and the sides are the extensions of each other. So OV is the extension of OU and XO is the extension of OY. Or in another word, XOY forms a straight angle. VOU forms a straight angle. Also, we have XOU, this angle, and VOY, also they are vertically opposite angles. They are asking us, are XOU and VOT, I'm gonna mark them, they are asking us about XOU and VOT, are they vertically opposite? No, because OT, as you see, it's not the extension of XO. So we cannot say that XOU and VOT are vertically opposite. Now, in question number 2, in the adjacent figure we have TAL, this angle is equal to 50. How can I find RAS? Look at this angle. We say that RAS is equal to TAL because both of them vertically opposite, so they have the same measure. We still need to find SAT. How do I find this? Well, I know that SAT is a straight angle. SAL, excuse me. So SAL minus TAL is equal to SAT. So 180 minus 50, it's 130. And now RAL is equal to SAT because they are vertically opposite angles. So they have the same measure, which is 130 degrees.